Sandra, and now I will talk about the copper. First, I will talk about the application of copper in construction. Copper can be simply divided into pure copper and copper alloy, in which copper alloys include the brass and bronze. The widely use of copper in construction industry is mainly due to its properties like high corrosion resistance, low thermal movement, and antibacterial, and also the cost effectiveness. Unlike other metals, pure unalloyed copper are often applied to some construction work. For instance, the roofing, indoor designs, and exterior cadence. While the copper alloys are also used for some outdoor walls. So these two are the examples of the application of copper in the world, like the audit and braces in Berlin and the Oak Park libraries in Chicago. Now move to the microstructure. Different physical properties of metals such as strength, toughness, and corrosion resistance can be determined from its microstructure. Rose copper. Rose copper refers to the unalloyed copper. The first type is electromagnetic tough pitch copper, ETP copper. This is the most common copper that consists of 99.9% copper and 0.045% oxygen content. This type of copper mainly uses for electro applications such as wine, rock pie production, because it has a high conductivity. Next, oxygen-free copper, which is namely OF copper. Being oxygen-free, this kind of copper, which consists of 99.95% copper and 0.001% oxygen. It is produced from the melting and casing of electro-refined cathode copper in an atmosphere with decreasing carbon monoxide and nitrogen content. It has a high conductivity and very high resistance to hydrogen embrittlement. Moving to the last part of the Rhodes copper, the phosphorus deoxidized copper. This copper underwent the deoxidization with phosphorus in order to increase the amount of oxygen in which resistance to hydrogen and embrittlement can be divided. However, due to the relatively high content of phosphorus presented in the copper, the electrical conductivity is thus reduced. And now I will talk about the brass. Brass is an alloy that mainly consists of copper and zinc, while other elements such as aluminium, magnesium, and lead can also be found in the brass, with a view to enhance the hardness and strength of copper. The property of brasses vary with the proportion of copper and zinc. Commercial brass can be classified into two groups, and they are alpha brasses and alpha and beta brasses. First, alpha brasses. The alpha structure of these brass contains up to 35% zinc. This is an increasing in the aniline twists in alpha glass with increasing zinc content. This can be observed when the alloy was undercoated and followed by aniline. The structure of this brass can also changes from cellular structure to panel array structure. With this, the increase of zinc content under observation from the microstructure. For low brasses, increase in the zinc content results on the increase in strength, hardness, and ductility, while the color will also changes from red to gold and to green yellow. Moving to the alpha and beta brasses. The alpha and beta two-phase structure of this brass has a high zinc content, which is more than 35% of zinc, in which the beta phase makes the brass a higher heat resistance. For high brasses, the increase in zinc contents increase the strength and hardnesses. However, ductility decreases due to the percent of beta phase in the brass. Here's another example of the alloys, and which is also namely the brasses. First, the lead brasses, copper lead alloy. It consists of a relatively small amount of lead with a view to increase its machinability. And the second is the tin brasses. It contains low zinc and tin content, which single alpha structure is formed. Lighter appearance can be achieved by increasing its tin content. Moving to the bronze. The bronze is a kind of copper alloy that consists mainly tin as its alloying material. There are many kinds of bronze, including the phosphate bronze and the aluminium bronze. First, I will talk about the phosphorus bronze. Unlike other bronze, tin bronze contains a higher content of tin and a low content of phosphor. It gives us a high strength and castability than brasses, which is suitable for fast products. And for aluminium bronze, this bronze contains 3 to 50% of aluminium with or without the addition of other materials. It has high strength, high corrosion resistance, and good resistance to wear. Now moving to the optical properties. Optical property refers to the response of material towards electromagnetic radiation and visible light. So let us look at the optical property of copper. Copper, similar to other metal, is opaque, that it is impervious to the visible light transmission. However, the copper is useful only in the red and infrared spectrum regions, as shown in this figure. And moving to the ultraviolet part, the weight of copper and copper alloy corrosion accelerates with the long-term exposure to ultraviolet light. This graph shows a greater weight loss under UV light than that in dark environment, which implies that UV illumination has an effect on the copper corrosion and the open circuit potential, which is namely OCP. The explanation of the above phenomenon is due to the formation of whole electron pairs in the oxide film by the UV photon, leading to the bending downwards of conduction and valence bands. The dissolution of copper oxide is namely due to the flowing of positive hole to the opposite direction and towards the water interface, in which the cathodic reaction is accelerated. Moving to the last part, the protection means. To tackle the above corrosion, Young suggested a method in 1995 that using titanium dioxide coatings to inhibit the corrosion of copper from UV illuminations, while the Subaris in 2004 suggested that heat treatment of 200 degrees Celsius also has a positive effect towards the induction of force photo effect on the copper. Now I will let Kathy talk about the glasses.